Git is so bad that you have to use an online tutorial to practice using it properly. You know, Git is supposed to be a decentralized source control tool. Yet, it is so bad at doing this job that it was meant for that you have to either do this tutorial, learn lots of complicated stuff, or use it as a centralized source control tool, which is the most ridiculous thing, because then you could just use a tool that's made for that type of thing. You know, most people just use Git with GitHub, and Git is super popular, yet Git is not fundamentally made for a centralized repository workflow. And it's bad for people who make games because they have lots of binary assets. You know, if you know this, you know. If you don't, you don't. But point is, I have tried to do this tutorial before. It was hideously complicated. It didn't work with my email provider, ProtonMail. That's mostly ProtonMail's fault. But I am making my own replacement for this. I am making my own tool. Now, fundamentally, for a decentralized workflow, what I want to be able to do is create patch files that are better than normal patch files, send them to people, and so they can merge them. So we want to be able to create files and do this kind of thing. And then I'm going to later on build a centralized bolt-on for this, so you can have a centralized repo. But basics first. So I created this program. It's called alt right now. That's a temporary name. The most basic thing we can do is here, you see we can do alt-C, that's for compare. You can see here I have the contents of this original text file. And then Alice has made some changes. She added this Lord of the Rings bit at the bottom, and she also added a title to the first poem. So, and we can also see here, you know, we have Bob. He's made some changes. He's added line numbers to the different poems. And so, you know, we can compare Bob as well. We get this diff that has deletions. We can compare Alice and Bob against each other. But comparing is only so interesting. What we actually want to do is we want to save this comparison with the -s flag as an alteration. So we say, you know, just like we had, you know, compare origin. And for this experiment example, we assume that, so original is some published version that everybody has access to. And then Alice and Bob have made modifications off of this original version. So we compare Alice, right? We did this before. Now we're going to do -s for save. And then we save this as Alice's work. Okay, and we get alterations saved in Alice's work. Now we can view this with -o, right? Very cool. We can view this, and this looks the same, but what's very interesting is this file is completely standalone. And it actually contains the original within it. And that's actually going to be very important when we go to merging later, right? Merging is not something these Unix patch utilities or something can do, but we can do that. So, for example, if I cat Alice's work, you'll see that, you know, we have some interesting binary stuff and then text. If I open it in my hex editor, you can see here we have you know, headers at the top, and then there's a text block. And just keep that in mind for when the next part we do. So right now we're going to create a new file here, or we're going to copy the original. And say we wanted to apply this patch. Well, we would have our merge.txt here. So if we look at this now, you know, we have the original file. If I now we're going to use -a for apply. So apply Alice's work to merge.txt. We see merged with no conflicts. Okay. If we look at our file now we have this title up top and this extra Lord of the Rings poem. Cool. What happens if we apply this twice? Okay, a traditional Unix, the sort of Unix patch command that informed the creation of Git. If we apply it twice, it's going to corrupt our file or maybe double insert stuff, or it's just going to panic and say, oh, I don't know what to do with this, okay? But because we carry the original with us in the patch file, we can do a three-way merge, which is the merge algorithm Git uses, but we can use it in this really, really decentralized way. Right, this is not a commit that we are applying or something. No, we are merging in this thing, so we do -a, Alice's work again, and we get merged with no conflicts. We can keep doing this, and nothing is happening because the our merge.txt agrees already with the changes, right? The tool can see that the changes are already in there, and so it doesn't have to do anything. Okay, now let's look at Bob, right? So what was Bob done in his file? He has added these numbers. Okay, so if will do the same thing, we'll do Alt-S for save the alteration, original to bob.txt, and we'll save that as Bob's work. Okay, and like before, we can now view Bob's work. There it is. And we can also apply this to our merge. Okay, and then we get merged with no conflicts. But if we look at the merge file, now we have our title and our lines here. This is Bob's work, and then here is Alice's addition as well. We can again keep doing this. No conflicts, no conflicts, no conflicts. We can apply Alice's again. Alice's work. No conflicts, no conflicts. And we can see that our merge.txt is completely fine. Which already we've surpassed, normal Unix tools. Again, there's no centralized server involved here. I can send this file as an email attachment. I can build a decentralized workflow around this, which is very cool. Now, let's take a look at Mark's work. So Mark has capitalized some of the words here that he thought were very cool. Or, this, I gotta give it to him. Fire and sword do look cooler when they are capitalized, especially in this font. So, we will suspect that we'll probably get a conflict here. So, if we do, save the alteration original to Mark as Mark's work. We can look, this diff is simpler here. If we view it, Mark's work, you can see here we're just replacing some lines. If we try to apply it though, we will now get a conflict. So we do Mark's work on our merge.txt. Okay, now we got these conflicts that came up because of course, Bob has done some work that touched the same lines, and so now this gets thrown to the user as in, that's Mark's work. You have to deal with this. So this is, as you would expect, quite normal. In here, as a user, we would have to say, oh, okay, let me resolve this, right? Let me see, okay, he wanted winter to be capitalized and mountains moon. Now, as is the nature with resolving conflicts like this, in this case, if we try to merge again, we will now receive conflicts every time, just because now our destination file disagrees with all, well, not all the patches, but it disagrees with both Bob and Mark. And so there we go. If we now apply the patch again, we'll see, oh, same thing. Probably, and well, in this case, if we accidentally do this, we can just say, no, take the version that I want. And the reason as well we get this big merge is obviously because the tool cannot see, these two lines look similar to us, but this line number is a pretty egregious change because it affects things a lot. So, we could say, okay, forget about that. We'll keep it as we want. What happens if we apply Bob twice? Well, similarly, we're going to have, I think we're going to end up with the same issue. You could argue that I should be detecting here that actually these lines are the same, and so the conflict zone is more narrow. And this is probably something I need to fix for the tool. You can always make things better, but as a start, I think this is very good. But yes, the main reason I had to make this is because, as some of you may know, I'm making an operating system and computer called Serenum, where I've rewritten everything from scratch. And one problem I've had is that as I do more development of that system on itself, then I need a source control solution for that, or a source control solution to sync up between my computer and Serenum, or even for a way for other Serenum users to make modifications and submit code back to me so that I can merge it in. And that's the function that this tool will be serving. I still need to optimize it a bit more because I implemented a more novel diff algorithm than the normal Myers diff or linear Myers diff that is used in existing version control tools. Fundamentally, it's similar, but it's I'll show you here. Actually, there's this great article. I highly recommend these articles by James Coughlin, or Coughlin, however you say that. He does a very good job explaining how these algorithms work. But fundamentally to all these algorithms is you have this square where you start up in the left corner, you go to the bottom right corner. Moving right means deleting something from the original source, from the original file, and going down is inserting into the new file. So, and the important thing that I think makes it less confusing is that any path from here to here is a valid diff. It's not what the science academia people would call a minimal diff, but it is a diff, right? But it certainly, some of these are worse than others. Delete the entire file, then insert the new file is a diff. It's not very useful. And so we have these diagonal links when something in the old file matches up with something in the new file, then we can walk diagonal, which is neither deleting or inserting. And so basically you're actually trying to path find yourself from this corner to this corner using the shortest path, where each one of these horizontal or vertical lines cost essentially one length, but the diagonal lines have 0 length. And so if these are the same file, then you can obviously just dart all the way down the middle. But if you have modifications, you need to sort of search around a bit to find these straight paths where you can make progress and get to the finish. And yeah, the algorithm I implemented is more of a it's less formally rigorous, but I think it actually has a better compromise, although I do need to optimize it. But the way it works is essentially I do an A star search with some number of active wavefronts that are valid, and so and then I'm obviously generating wavefronts, new wavefronts the whole time. Because say if you're at this point, then you're going to generate this point and this point, or if you're here, you're going to generate 3 new points. And then I score the wavefronts based on their, the smallest path length and how close they are to the finish, and then prune. So I have some max number, because otherwise you balloon. Otherwise you end up doing Myers diff, essentially. Myers diff is just do Dijkstra's algorithm on this square. And linear Myers is a way crazier way of finding a minimal path through here in a way that uses a linear amount of memory, because obviously this square is a square. So if this side is big and this size is big, which will happen if your files are big, then you can easily end up with requiring multiple gigabytes of memory required to do the Myers diff of this thing. Now the thing that sucks about linear Myers, which is the one Git uses, is that it produces diffs that suck. As Git users will know, you just get that really horrible diff where if you move a procedure below another procedure, it will say, oh, I changed the signature, then the curly brace is the same, and it'll basically replace each line, which is really horrible. Because what you wanted was delete the entire function on top and then insert it on the bottom, which if you run a normal Myers, the one that requires lots and lots and lots of memory, that one will just produce the good perfect diff that you wanted by default. And so the algorithm I have is starting with Myers diff and then saying, can we do a Dijkstra's algorithm, but we don't search everywhere. We search in a subset of the space, and then we won't be algorithmically guaranteed to have found a minimal diff, but we can find actually a pretty good diff if we just have some good heuristics for how we're looking through and how we're pruning stuff. What you end up doing is sort of moving through what actually both algorithms that use mine or linear Myers that use a low memory usage is that you are kind of breaking up the problem into smaller chunks, and that's as what you would do as a human as well. So that makes sense. Anyway, yeah, I need to optimize that more, and then probably this tool will be in the next Serenum release. So people will be able to use it. I also need to optimize it so that it's not hideously slow or uses too much memory on Serenum, because obviously that's a lot weaker of a platform. And hopefully, so the next Serenum release, as people know, I am working on Wi-Fi. And the initial release of Wi-Fi will only contain a program to chat with the Discord server. We're going to have a bridge set up. But after that, I'm probably going to be working on an actual sort of email-like new protocol so that we can send emails back and forth. And then I think the workflow for collaboration will be sending these types of patches with this tool over that new form of email. Because fundamentally, I won't know if this tool is good or not, or how I need to improve it, until I've spent a lot of time using it. And the only way to use it is, of course, to use it. So, anyway, I hope you found that interesting or learned something. My name is Sam Smith. if you're interested in what I do, go to samhsmith.com. You probably want to go to samhsmith.com/serenum. That's where the interesting stuff goes. Or, I have other YouTube videos. So, have a nice evening.